What did you have for your answer?
A substance that can be decomposed by chemical means to simple substances.
Okay, what's the definition for it? Because it was,
Compound.
so your problem was to like define something. So
Yeah,
what was your
compound.
complete sentence?
Compound.
Good job. So yeah, so a compound is it is defined as a substance that can be decomposed into smaller substances. So generally it's made up of what, Ethan?
What?
Okay, so if you have a compound, what's it typically made of?
Two things.
Okay, two the same atoms or different atoms? Different atoms. So just make it up that. Alright, define mixture, Chris.
I just need to know if I have, like, I can tell you what it is.
Okay.
Mixture isn't a mixture two different atoms that are together?
Are they hooked together or are they just next to each other?
They're just next to each other.
Good job. So they are physically mixed but not chemically combined. Be sure to write like it's pre-lab, so that way you won't forget for a second. Okay. Alright, number 3. How can a compound and a mixture be differentiated in a laboratory? Did you find it yet, Chris?
Absolutely.
Did you put it in your lab book?
Pieces of it.
No, I just know you asked me about it yesterday, so I didn't know if you just shoved it in there. Alright, we'll go back to Ethan then. Alright, Ethan, how can a compound and mixture be differentiated in a laboratory?
I had mixtures would have different substances, like 2+ substances in it, and compounds have only 1 substance in it. So,
Okay, you can probably. So, how can I tell the difference between a substance like salt water? So, if I want to separate the salt from the water, do I have to use a chemical reaction or can I use a physical means to separate?
chemical. You can't separate. Oh, you can.
Okay, so how can I?
Physical.
I got it.
You found it?
Yeah, it was in my US history.
Oh, okay, good. All right, so you can separate a mixture by a physical process, so like evaporation. You can separate it, or like how we talked about.
I thought it was like how they do differentiate. I thought they do differentiate their chemical properties.
Oh, partly yes and partly no. So it's asking how do you separate them out? A compound you can only break apart because they're chemically bonded together. You can only break it apart by a chemical means. It's a chemical reaction to break those bonds. Like for water, in order to break a water compound, you have to physically, basically electrocute it to make it separate that sport, and it's a chemical reaction because the oxygen and the hydrogen are separating. If you were to have salt water, so sodium chloride, the sodium and the chlorine has just dissolved in the water, but it's not bonded to the water molecules themselves. They're just next to each other. So you can separate them out by physical means, like evaporation. Or a filter in some cases.
As a chemical reaction or physical reaction, like stuff that we went over yesterday, is it maybe chemicals?
Yes, possibly.
Kind of chemical.
Let's go over question 1.5 real quick. Alright, without consulting anyone, write 3 observations related to the weather at noon yesterday. Okay, like, I'll take a bunch of different stuff, but if you're right, we had like a hurricane yesterday, then you're clearly wrong.
So-
Okay,
Yesterday was sunny, hot, and torturous.
I said sunny, hot, and humid.
that works. So sunny, hot, humid. It was slightly breezy on Wednesday, if you're thinking about Wednesday. So it's one of those, as long as you were close, but I'm not going to go through and be like, huh, you said hot instead of mild.
You said
Wrong.
98 degrees, not 97.
Yeah, so we're not doing that. It's one of those, okay, as long as you were close. Alright, without consulting anyone, write 3 observations concerning your chemistry teacher. Eye color, hair color, glasses or no glasses, height, clothes worn yesterday, etc. And so the point of those 2, question 4 and question 5, was to help you see how much are you observant in nature. Now some of you might be really observant, some of you might not.
If you
Alright,
look at their clothes,
alright, Chris,
they're
what'd you
kinda
write?
creepy. My chemistry teacher is short, probably 5'5", brown hair, no glasses.
Did you say glasses?
No glasses.
Okay, I'm about to say, Chris.
Was I right with the height? 5'5"?
Close, 5'2", actually.
Not
Yeah.
really that close.
And so, I mean, you were approximate,
So you think
you-
a whole foot taller than me?
What? Yeah.
I'm like 11 inches tall. That's crazy.
Alright, but I mean, that's just so it's one of this now. Typically, girls notice clothes more than guys. This will come. Now, Jamie might know and might remember what I was wearing yesterday or the day before. But Quentin probably doesn't, but that's okay.
If you remember what she wore yesterday, you're kind of a creep.
But I mean, people just know, like, girls notice shoes and other things like that. So it's one of those, you might not remember and might not care. That's just part of it. Alright, so let's go ahead and let's review. Pick up these papers so you can write down stuff you don't know very quickly. So that way we can hopefully go through this. We're just going to do it rapid fire because I got to move so that we can watch the lab and have a lot of time as well for it. Alright, speaking over it. Alright, Ethan, what is the energy of motion?
Kinetic energy.
Good job. What is often defined as anything that occupies space and has mass?
Matter?
Good job. Alright, what is the indirect measurement of a particle's average kinetic energy?
Temperature.
That's it. Alright. Alright, which state of matter, solid, liquid, gas, plasma, that's one I forgot, has the most kinetic energy?
Plasma.
Which one has the least kinetic energy?
Solid.
Which one has a definite shape and volume?
Solid.
Which one, the molecules, they have definite volume, but they can flow around each other?
Liquid.
Liquid. And then which one have enough energy now to break apart from each other and separate?
Gas.
Gas. And which one they separate into ions?
Plasma.
Plasma. Now keep in mind they're not going to be in order on the quiz, so make sure that you know
That's
it's
No, that's not. I
What?
don't care about
That's gonna be on the quiz.
maybe. What do you call the transition states between a solid and a liquid?
Solid to liquid.
Solid liquid.
That's melting point.
Good up, and then liquid to a gas.
boiling point.
Good job. What's the most abundant state in the universe?
Plasma.
Plasma, because we can use probably with stars. Alright, what do you call a substance that once you break it down into its individual atoms, it's still that same substance? What do we call these?
Element.
Yep, I'm trying to think how can I describe it. But yeah, elements. That
Like
it basically
copper
you
down
break,
to
yeah,
copper.
basically you break it down to copper, you have one atom of copper, or one atom of gold, or one atom of oxygen. You break it apart anymore, you don't have oxygen, you have like the protons and neutrons at that point.
It's not proven that the most abundant resource is plasma, is it?
It's one of those, well, because our sun is made up of plasma, it's safe to assume that all stars are made up of
There's
plasma.
blue stars and different things like that.
That has to do with light though. So, because of the frequencies of light over how our eyes perceive it, we'll talk about light actually later on in chemistry. Because the light coming off of it, our eyes interpret it as
UV
those
lights.
colors. And yeah, or UV light, they color code them to see how the light's coming from it, but our eyes can't see that at that point. So again, they still think that they're all hydrogen, and there's other stuff mixed in with it to partly give them colors, like nitrogen. But then, okay, because it's so hot, that it's probably plasma, so it's a good guess. Like, it's a good educated guess, but again, you can't prove it. Alright, what do you call this? A two or more atoms just hooked together. What do you call just two or more atoms hooked together? Technically, it's your turn.
Technically, it's not.
I just said element.
He
You
said
said element? Yep, you're right.
not hooked together.
So what do you call two or more atoms just hooked together?
Same atom.
Same or different, could be either.
Let's start with
M.
mixture.
Nope.
Molecule.
Molecule.
Oh!
Alright, two or more different atoms
Right now.
specifically.
Mixture.
No.
What? Two more.
Alright, you did. Two or more different atoms hooked together.
Compound.
Compound. Okay, so for you, Chris, make sure you're paying attention for it. Two or more atoms just hooked together, chemically combined, molecule. Two or more different atoms, still a molecule, but now it's a compound specifically. Okay, you got it? Awesome.
Different
Alright,
molecules put together.
different molecules, compound. Alright. Alright, what do you call a substance that is two or more substances that are mixed together, but they're not chemically combined?
Mixture.
Yes, now that's mixture. Alright, what do you call a mixture that's all the same type all the way through? So it looks the same.
Homogeneous.
Homogeneous or homogeneous? What do you call if it looks different, where you can see there's other parts mixed up in it?
Heterogeneous. Heterogeneous.
Heterogeneous or heterogeneous. There's a different way of saying it. Okay.
So a compound is two of the same. Mixture.
Nope. Compound is two or more different
Different.
atoms, like water,
Okay.
hydrogen and oxygen, hooked together.
And then
Compound.
mixture is two.
And-
They're not hooked together.
Yeah, they're just sitting next to each other.
Okay.
And then molecules is two same.
It could be same, it could be different. So a compound is a type of
So that's a
molecule.
molecule and a compound.
Yes.
Element is just things broken.
Yes. So, like, if you have pure oxygen, okay, so this is a molecule, this is a molecule. Is this a compound?
No.
No, because it's the same. This is a compound.
Which one is it that it's two of the same together?
Diatomic
Oh, wait,
molecule.
that's not gonna be on the quiz, is it?
I'm not there yet. What's the name for it? Let's see. What is an example of a diatomic element besides
Oh,
oxygen? 'Cause I
okay.
clearly just said that's one. Alright, so remember there are 7 you need to know from the periodic table. Sorry, Jamie, you can't see it. Okay.
Fluorine.
Wait.
Iodine.
I think you just went.
I said there.
Fluorine's one. So remember,
Iodine.
it's for nitrogen on the periodic table. So look at your own periodic table, Jamie. Nitrogen through iodine, and then also hydrogen. You just want to remember hydrogen as being the easy one. That's an example of a diatomic element. All right, what was your question?
Keep forgetting Quinn.
Oh, I'm Quentin. I'm sorry, Quentin. I'm sorry.
Every day
I
we
know.
forget Quinn.
Quit probably crying.
All right, what is a homogeneous part of a system that's in contact with but physically distinct from other parts? So like water and oil, they don't like to mix together, so they try to stay, like all the oil stays on top of the water. So what do you call that whenever they separate out like that?
Let's
What?
start with.
Pete,
Say it again.
what do you call a homogeneous part of a system that is in contact with but physically distinct from other parts? Right, Chris?
Where's the P?
There's Pete.
Platonic.
phase, write down,
Oh,
phase,
yeah.
phase,
F-A-Z-E.
phase,
I knew
phase,
that.
phase.
Phase 4.
That helps you remember.
Phase 8.
Alright,
Phase 16.
who came up with the atomic theory?
John Bell.
Good job. Alright, and then what is the law that was part of John Dalton's ideas? But the law that says that the ratio of the masses in a compound are always the same. What's the name for that? The ratio of the masses in a given compound are always the same. Like
What's the
water's
name of the law?
always 11% by mass, and for the hydrogen, and 89 one round up. For the oxygen, always, always, always. If you don't have this, it's not water.
What's the name of the law?
Yeah, what's the name of the law?
Law
Law of, and then D.
Law of diatomic something?
Nope,
This is gonna be on the quiz?
The
Maybe.
second one starts with the C or B.
there's C.
Second one is, I don't know.
Okay, definite composition.
That's what we're-
Definite composition, always the same with the masses of the compound. So it's always 11% hydrogen for water and 89% oxygen. Alright, what's the second part then? That says, whenever you have two elements that can combine to form more than one compound, like water and hydrogen peroxide, that the masses of one element that combine to a fixed amount of the other element are in a ratio of small whole numbers. So how they combine together is a ratio of small whole numbers. Starts with an M. You
And
know the
then
first
a
one,
P,
probably don't know
right?
this one.
M and then a B.
Yep, maybe you know it then.
M and then a P?
Yeah, it's the first word's an M, second word's a P.
I remember the
Was that the, that's ASL, right?
Yeah, American Sign Language.
Okay,
That's why I keep doing
Law-
like signs like this, because I know the basic alphabet, but not a lot of other things.
law of molecular,
Nope. Alright, multiple proportions.
Multiple proportions.
Multiple proportions. So think of it, multiple, there's more than one. Proportions has to do with algebra, so like the ratio. So multiple proportions. Alright, anyone have any quick questions?
Okay, so tell me which again? For
Definite composition. Law of definite composition. So if you have water, it's going to always be 11% hydrogen, 89% oxygen. So the masses are
There's
always
two
the same.
different-
Always the same
Are you
for it. So
reading
it's
it?
definite composition. The masses of the compound are always the same.
Okay, and a multiple proposition is,
If you have two different compounds that you can have the atoms form into, like this is still hydrogen and oxygen, the ratio from to compare this compound over how they bond to this compound is in small whole numbers.
so what's
it's
the
like a one
definition
sheet.
of definite?
Okay, the book says, for the second one, this states that when two elements can combine to form more than one compound, the masses of one element that combine with a fixed amount of the other element are in a ratio
Okay.
of small whole numbers.
I remember that.
I think for ratio, that's kind of like the key word. So
Proportions?
proportions, ratios, that's like the same algebraic term. Okay.
Definite.
two things. Are we gonna review, at the end of class?
Probably not, I'm gonna run out of time.
And
Yeah.
is my, paper from US History graded?
That's not important right now. Alright, any question about this? Alright, go ahead and take out two pieces of paper, pen and a pencil, not this one, two pieces of paper, pen and a
Here?
pencil.
Do we need?
Oh, well, technically I guess you only need one because you're so far apart from each other, you can't cheat off each other, but you need that one piece of paper. At least if I see you looking, I will move you to the other half of the room.
Yeah, I can't see that far.
So, one piece of paper, pen, technically you need a pen right now, because Rona, we can't grade in class. Right, name, date, top. What about just chemistry quiz? That's fine.
The date's wrong on the board.
I know, I noticed it earlier, junior high already told me to come and fix it yet. Today is the
Did
21st.
Audrey tell you?
What?
Audrey told you?
I think it was Jaden.
Who?
One of the junior hires told
Oh,
me.
Napoleon Bonaparte.
Okay, no. Alright, so, number one.
Wait, quiz what?
You can just write chemistry quiz. I believe this is chemistry quiz number 3.
Alright.
If you just write chemistry quiz, I know which one you're talking about and I'll fix it later. Number one. What is defined as anything that occupies space and has mass? What is defined as anything that occupies space and has mass? Number two. What is the energy of motion? What is the energy of motion? Number three. What state of matter of the 4 states of matter is probably the most abundant state of matter in the universe, based on good educated guess? What state of matter is probably the most abundant state of matter in the universe? Number 4. What state of matter do the atoms have enough energy to break away from each other and try to fill up the container as much as possible? What state of matter Is it whenever the particles of this, whenever the particles of the matter have enough energy to break apart from each other now and try to fill up the container as much as possible? That's question number 4. Alright, number 5. Name a diatomic element. I don't care which one. Pick one, you can write the abbreviation for it. Write a diatomic element. Yes.
Can you give me a look at this and tell me if this is okay? Like, not if this is okay. I know it's wonderful, but like, can I just write that?
You may write an atomic symbol for it, so as long as you are very clear what the atomic symbol
that's
is,
okay?
I'm not going to tell you. Make sure you write an atomic symbol. If that's the atomic symbol for it, then write it. Number 6. What do you call a substance that can be decomposed by chemical means into 2 similar substances? It's made of 2 different atoms. What do you call specifically that type of substance that's made up of 2 different atoms that are hooked together? What?
Say it again.
2 or more different atoms hooked together. What do you call that type of substance? Number 7, what do you call an homogeneous part of the system that is in contact with, that is physically distinct from other parts of the system? Like whenever you mix water and oil, the oil wants to sit on top of the water. So it's homogeneous, the oil, but it is physically distinct. It's different, but it's all together in that one section. So an homogeneous part of the system that is in contact with, but physically distinct from the other parts. Number 8. What do you call a solution or a mixture or a substance that is composed of the same type of matter all throughout it? So it all looks the same. What do we call
Like
that?
it
Whenever it
doesn't change?
is, what?
Like it doesn't change?
What do you call a substance? Like if you were to have salt water, it all looks the same all throughout it. So what's the term that refers to that it all looks like the same substance all the way through it? It's composed of the same type of matter all throughout. This could be a pure substance, like a pure bar of gold, or it could be like salt water. So just what do you call that whenever it's all the same all the way through it? Number 9, who proposed the atomic theory? First and last name. Who proposed the atomic theory? Alright. Just wait, I gotta go through the last question. Number 10. Alright, there are 2 laws that have come off the atomic theory. What is the law that states that the ratio of the masses of the element in a given compound are always the same? So like if you have water, it's always 11% hydrogen and 89% oxygen. So the masses are always the same in the compound. What is that law? So write law of, and then give the name for it. Alright, Chris, what's your question?
If you mess up the first name on number 9,
Spelling here.
okay, so it's just my son.
Yeah, it's just a nice one. Yeah, it's just a nice one. I'm consistent in history and chemistry in that.
Is there a phone next time?
Alright, anyone need anything repeated though before we move on? Alright, so I'm gonna come through and collect it. Jamie, I'm gonna go ahead and stop and Quentin, I'm gonna go ahead and stop the video because whenever I show it on the screen, it doesn't get picked up on the Mevo. So we're going to watch lab 4. We're gonna skip lab 2 and 3 for right now, so that way we can do those in class. Lab 4 is in lesson 12. So Jamie and Quentin go over to the Abeka video and watch lab 12. It's only 27 minutes, so you should be able to finish it in the class remaining. The report sheet is due Monday. I'm going to go ahead and tell you the homework now because it doesn't quite match up with the homework that he gives you in the video. So my students, you can go ahead and get out your atomic pods as well, so you can also note what the homework is. So note for the homework, you're going to read pages 26 through 30, and answer on page 30 questions 2 through 5. So on page 30, questions 2 through 5. Jamie, Quentin, if you want to skip the first few minutes of your video, you can because he's going to go over the homework that we just went over in class. So if you want to skip forward till the lab actually starts, that's fine. Alright, I'll say it one more time. You're going to read pages 26 through 30, and then on page 30, you're going to answer questions 2 through 5, plus the report sheet is technically due Monday, so you have the weekend to work on it if you don't finish it in class.